So here we are in example B from 7.8, and it's about finding these roots when they're not so obvious. So what we've done with example B is we've gone to our graphing calculator, and we went ahead and we put this in for y1, and we're going to take a peek at the graph, and it looks like this. It's not really obvious that, oh, the roots are 1, 2, and 3, like yesterday. They look like, how should we say, tweeners. You know, they're kind of in between some integers. So we can't really tell exactly what they are. So the rational root theorem is around. Go ahead and read it. It's in the yellow box here. The rational root theorem is around to help us make a list of potential suspects. So our analogy of the day is that somebody committed a crime. And that crime is they made this equation become 0. All right? They made the graph hit the x-axis. That's true. So we're trying to find out who did it. So we're looking for potential suspects. Well, what would be easier if you were an actual investigator and you had to look through a list of every person that exists in the country or 6 people? What would be easier to sift through? 6, right? Wouldn't you like to narrow it down? The rational root theorem is the key to narrowing that list down. Okay, the list of suspects. So, here's what it says. If it indeed has rational roots, okay, if the function has rational roots, they're going to be of this form, p over q, where p is a factor of the constant term. The constant term is the number on the end, negative 25. So our list of candidates is going to come from P and its sidekick Q. Q are the factors of the leading coefficient. The leading coefficient is the coefficient of the biggest degree, 3. So the Q is going to come from the 3. So what we do is we start by making a list of factors of 25. In other words, what are some numbers that multiply to make 25? 5 and 5, only list it once. 5, 1, and 25. Those are the whole number factors of 25. I know you could do 12 and a half times 2, but we're not going to count them. Okay, only whole numbers. Q in red will be the factors of 3. So you look to the beginning of the function for Q and the end of the function for P. All right? So again, we're trying to narrow our list down of who committed this crime, of who made this equation equal 0. That's the case of the day. Well, the factors of 3 are just 1 and 3. That's it. 1 times 3. Those aren't the potential suspects. Those aren't the people who you would line up at the police station behind the one-way mirror glass. You know what I mean? And say, that person did it. That person did it. Those aren't the suspects. No. The suspects come from listing P over Q. All the different combinations of P over Q. That's going to be our list of who maybe did it, who might be the 0. So, what I want you to do is just go right down the line and do this P over this Q, then this P over this Q. So our candidates are 1, 1/3, then do 5 over 1 and 5 over 3. It's possible that some of them could show up twice, and if they do, you don't have to list them twice. That would be like asking a person in one of those police lineups to stand in 2 places. That's why. That doesn't make sense, okay? So there are 2 more. One is 25 over 1, and the order doesn't matter in how you list them, but the order does matter. You can't do this. You don't do 3 over 25. No, 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 no. You only do P over Q. Okay, so what was 25 over 1? And then finally, 25 over 3. Now, I don't know if you know anything about, police shows or detective shows. They're all over television, right? And movies, and maybe you've been involved in some cases. I don't know. I don't know about your history. But what happens is, don't they kind of use different tools to narrow their lists down? They might look at surveillance. I hate this word. Surveillance tape, right? Video. They might ask around who was there. They might ask for witnesses. They might look at fingerprints, things like that, okay? So what we're going to do is we're going to use our listing of potential candidates now and use our personal surveillance video, which is our calculator, to see if we can rule out any of these suspects. For example, do you think 25 is one of them? Is 25 on this screen right now in terms of the x's? No. I'm pretty sure that since this is a degree 3, it hits once, twice, 3 times, done. Okay? So to me, 25 didn't commit this crime. It's not even in the neighborhood. Okay? So 25, I believe, we can rule out. 25 thirds is like 8.3 repeating. Does this graph look like it crosses at 8.3? My window, I'm sorry, is 10 to 10. Does it cross over there at all? No. So I think we can rule out 25 thirds. What about 5? If you're not sure, here's what you can do. Using your calculator, if you think 5 could be someone who committed the crime, press trace 5 and check. Make sure you're on the graph and press trace 5. Enter. Did 5 produce 0? No. So 5 is not a 0. Yeah. Go for it. So let's hit trace 1, trace 1/3, trace 5/3. 1. 1 is not the bad guy. 1/3. 1/3 is innocent. 5/3. Ooh, 5/3 is innocent too. 5/3 produces negative 22. So are any of these guilty? No, none of them produce 0. But we only listed all of the positive suspects. All of their negative evil twins are also suspects. Okay? They're alter egos. No. I think it was either -1, -1/3, Colonel Mustard, -5/3, Miss Peacock. Those are characters from Clue. Okay. All right. Those are the potential suspects as well, the negatives. So let's check them. How many are we looking for? 3. It looks like 3 people did this. 3 numbers, actually. Who do you think it is? Let's check -5/3 because we seem to be eager to check it. Haha, -5/3. Guilty as charged. But wait a minute. All right, let's go ahead and write that down. One of the roots, should we call it root 1, is -5/3. It's under arrest. Okay, that was bad. All right, it's one of the roots. Whether it's root 1, root 2, root 3, doesn't matter. Whatever. Okay? The question is, we ruled out all the positive numbers. Does that bother you in looking at the graph? So it does cross at a positive value, but it's not one of those rational suspects. No, it can't be imaginary if it can't be imaginary if you can see it. Well, there's imaginary, there's rational, irrational. It must be an irrational root. it's one of those criminals that's just so irrational you just can't seem to track them down. Okay, here's what I'm going to tell you. It is an irrational root and his evil twin. So if we find it to be positive some irrational number, I think the other one's going to be negative same irrational number. So now we need to find that missing irrational number. Do you think it's the square root of 5? That's a good prediction. Let's find out. And we'll find out if the square root of 5 and the negative square root of 5 is the guilty suspect in the next video, entitled Example B, Part 2.